Some examples on limit superior and limit inferior. Okay, so first example is let sequence Sn where n runs from 1 to infinity is equal to suppose -1 raised to n. Find limit superior and inferior. Okay, so how to find the limit superior and inferior? But before, what is meant by limit superior? Limit superior means if set Mn is equal to supremum of Sn plus 1, Sn plus 2 up to so on, then Mn is a non-decreasing sequence and which is bounded below, then Mn has a limit. So using this definition here, let sequence Sn where n runs from 1 to infinity is equal to sequence here given that -1 raised to n where n runs from 1 to infinity. Therefore Sn contains elements 1 minus 1 1 minus 1 minus 1 plus 1 minus 1 plus 1 minus 1 up to so on in this way. Okay, therefore limit superior Mn is equal to supremum of Sn plus 1, Sn plus 2 and up to so on. Therefore supremum of Sn is -1 1 minus 1 1 and up to so on. Their supremum must be 1. Therefore limit n tends to infinity. Here m1 m2 m3, why not satisfy? Why not finding here? Because all mn are equal, because here 1 1 1 are m1 is equal to 1, m2 is equal to 1, m3 is equal to n and so on. All elements of mn are equal. Okay, so therefore mn is equal to 1. Here we directly write mn is equal to 1. Okay, so limit n tends to infinity, supremum of Sn is equal to limit n tends to infinity, mn is equal to limit n tends to infinity, 1 has limit is 1, and therefore limit inferior is equal to 1. Similarly small mn is a infimum of Sn plus 1, Sn plus 2 by definition of inferior. Okay, in this way infimum of -1 1 minus 1 1 and so on. Therefore infimum of this smallest element of this all element is -1. Okay, so for each mn is a constant sequence here exists, and constant sequence is bounded sequence. So therefore which is bounded above, therefore limit is -1. Okay, so limit infimum is equal to limit n tends to infinity, infimum Sn is equal to limit n tends to infinity, small mn has value is -1. We get a value, answer is -1. Therefore limit superior and limit inferior are 1 and -1 respectively for this sequence. Okay, so then next example sequence Sn is equal to where sequence Sn is equal to -1 raised to n into 1 plus 1 by n where n runs from 1 to infinity. This is a given sequence. Okay, so how to finding their limit superior and limit inferior? Find their limit superior and limit inferior. How to find in limit superior and limit inferior? So here let Mn is equal to supremum of Sn plus 1, Sn plus 2, and up to so on. Okay, therefore supremum of Sn when n is equal to 1, then value of this Sn, first term of Sn is when n is equal to 1 means minus 1 raised to 1 is minus of 1 plus 1 by n. Then second term is when n is equal to 2, then second term is 1 plus 1 by n when n is equal to 2. Then okay, and when that is when n is odd and n is even. Okay, suppose that if n is equal to 1, then their value is minus 1 upon 1 by n. Okay, then n is 2, then minus 1 raised to 2 plus 1 plus 1 by 2. Then n is equal to 3, then minus of 1 plus 1 by 3. If n is equal to 4, then 1 plus 1 by 4. And in this way all values of this sequence are exist. Okay, so putting n is equal to 1, then we get a value minus 1 plus 1 by 1. When n is equal to 2, then minus 1 square is plus 1 plus 1 by 2, and so on. In this way we get a values of this sequence. Okay, so we finding 1 plus 1 by 2 1 plus 1 minus 2, 1 plus 1 2, and we get a minus 2. Here 1 plus 1 by 2 is 3 by 2. This is 3 by 2. Then their value is 4 by 3 minus 4 by 3. Okay, then next value is here 1 plus 1 by 4 means 5 by 4. Then and up to so on. In this way we get a values. Okay, so m1, first term of this mn is m1 is supremum of all these elements. Supremum of all these elements is therefore supremum of m1 is equal to supremum of these all terms. These all terms are minus 2, 3 by 2, minus 4 by 3, 5 by 4, and up to so on. In this way we get a first term. Okay, then second term m2. How to find m2? M2 is again a supremum of this term, but here m1 is largest term. Here is 3 by 2 means 1.5. Then their value 5 by 4. 5 by 4 has value is 1.2 something. Okay, means all of these values are less than 3 by 2. Okay, their value is 1.5. Then supremum of all these elements is, then their value is 1.2 something. Okay, then their value is 2.5. Okay, then next value is 7 by 6. Okay, next value is 7 by 6. Okay, here minus 6 by 5, then 7 by 6. 7 by 6 means 1.11 something, means all of these values are less than 1.5. Therefore supremum is 3 by 2. m1 is equal to 3 by 2. Okay, then m2 is supremum of minus 2, minus 4 by 3, 5 by 4, and up to so on. In this way then their values must be 5 by 4. Okay, then 5 by 4, and in this way mn is supremum of mn is value of mn. Okay, lastly lastly value of Mn is supremum of 1 plus if this n, if this n is even, this n is even, suppose for if n is even, okay, if n is even means for second, then first value must be 1 plus 1 by n, then second value 1 plus 1 upon n plus 1, because this is the next value, okay. Then third value is plus 1 plus 1 upon n plus 2, and in this way all values, okay, in this way we get all values of Sn, okay. If n is even, then minus 1 raised to u1 power is plus 1 and 1 plus 1 by n, okay. And if n is odd, when for this condition is if n is even, and if n is odd, then value of Mn, is supremum of minus 1 plus 1 by n, then plus 1 upon n plus 1, because n is odd, then minus of 1 plus 1 upon n plus 2, and up to so on, when this values exist if n is odd, okay. Because if n is even, then value of this, if n, putting n is even power, okay, even power minus 1 raised to even power is positive, and so get first value is suppose 1 upon 1 plus n, then Sn plus 1, second value is n is first value is even, then second is odd, n plus 1 is odd, then minus 1 raised to n is negative, okay. So then putting minus of 1 plus 1 upon n plus 1, then third value is minus 1, n plus 2 is again even, so even minus 1 raised to u1 power is even, then 1 plus 1 upon n plus 2, then fourth value, and up to so on we get this value are exists. Similarly for if n is odd, okay. And therefore in both cases Mn is must be 1 upon n, 1 plus 1 upon n, because this value is the highest value of all these, this value is a greater value in all these elements, okay. Therefore Mn is equal to 1 plus 1 upon n, and therefore limit n tends to infinity, Mn is equal to limit n tends to infinity, 1 plus 1 by n. When value putting n tends to infinity, we get an answer is 1, okay. And therefore limit superiority of given sequence is 1. Similarly for infimum, let small mn is infimum of Sn plus 1, Sn plus 2, and up to so on, okay. So m1 is here we does not find m1 m2, we directly use this formula. If when n is odd, then value of Mn is equal to infimum of when n is odd, then minus 1 plus 1 by n, then second value is 1 plus 1 upon n plus 1, then third value is must be 1 plus minus of 1 plus 1 upon n plus 2, okay. This is Sn, this is Sn plus 1, this is Sn plus 2, and up to so on. In this way infimum of these all elements is infimum of means very less than value is must be this value, because this is a greater value, 1 plus 1 upon n is a most greater value, and their negative is a very smallest value in all these terms, okay. So therefore Mn is a minus 1 plus 1 upon n, okay. and if n is odd, and for second, if n is even, then mn is equal to, if n is even, then mn is equal to 1 upon 1 by n, then minus of 1 plus 1 upon n plus 1, because this is Sn, put n is equal to n, this is Sn plus 1, put n is equal to n plus 1, then next term of this putting n is equal to 2, suppose that. Okay, in this way we get a values. So in both cases, in this term, if n is odd and if n is even, in both cases smallest value of all this term is must be minus of 1 plus 1 by n. Therefore mn is equal to minus of 1 plus 1 by n, and therefore limit n tends to infinity, mn is equal to limit n tends to infinity minus of 1 plus 1 by n, then putting value of n tends to infinity, we get 1 upon n is 1 upon infinity 0, and we get a minus 1. This is the infimum of Sn, that is limit n tends to infinity, infimum of Sn is equal to minus 1. Okay, so this is our infimum and supremum. So next example, find limit inferior and superior. Find limit superior and inferior. So for sequence Sn, where Sn runs from 1 to infinity is equal to minus n. Then second sequence Sn, where n runs from 1 minus infinity to find n. Okay, and up to so on. In this way, find their limit infimum and supremum. Okay, so for this mn is supremum of minus 1, but minus 1, minus 2, and up to so on. This sequence is a bounded this sequence is a bounded above by minus 1. Therefore m1 is equal to minus 1, m2 is equal to minus 2, and up to so on. Okay, because supremum of all this term is minus 1. Okay, we get minus 1, we get delete, then m2 is equal to minus 2, minus 3, minus. Okay, here direct we write here m1 is equal to supremum of minus 1, minus 2, up to so on, we get a minus 1. Then m2 is equal to supremum of minus 2, minus 3, we get a minus 2, and in this way mn is equal to minus n. Okay, mn is equal to minus n, and therefore limit n tends to infinity minus n, their limit is infinity. This is their limit is does not exist. Okay, so similarly find for this. Okay, in this way their limit is also does not exist. So here next example, suppose that n divided by sequence Sn is equal to n divided by n plus 1 when if n is odd and 1 upon 1 n plus 1 or 1 plus n when if n is even. So given sequence is of the form of n plus 1, and if when n is odd, and if n is even, then their value is 1 upon n plus 1. Okay, Sn, where n runs from 1 to infinity, which imply that here let sequence Sn contains elements. If n is even, then value is 1 upon n plus 1, and if n is odd, then value is n upon n plus 1. So if we putting n is equal to 1, 1 is an odd number, therefore value is 1 upon 1 plus 1. Okay, when putting n is equal to 2, 2 is even number, so put the value is 1 upon 2 plus 1. If n is equal to 3, then 3 is odd number, so putting the value of this 3 divided by 3 plus 1, and up to so on. Then 1 upon 4 plus 1, then 5 divided by 5 plus 1, then 1 divided by 6 plus 1, and up to so on we get a terms of this Sn. Okay, so mn is equal to supremum of Sn plus 1, Sn plus 2, up to so on. So putting their value supremum of Sn, their supremum of Sn is suppose that supremum of this all term 1 upon 1 plus means this is 1 by 2, then 1 by 3, then 3 by 4, then 1 by 5, then 5 by 6, then 1 by 7, then 7 by 6, 5 by 6, 7 by 8, and up to so on we get a elements of this Sn. Okay, so therefore Mn is equal to, in this way Mn is equal to supremum of 1 upon 1 upon 1 plus 1 upon 1 plus 1, or here m1 is equal to so we put m1 is equal to supremum of 1 by 2, 1 by 3, 3 by 4, 1 by 5, 5 by 6, and in this way. Okay, so their value is here when n is equal to when n is equal to 1 is equal to, when n is equal to 1 is odd, 1 upon 1 plus 1 by 2, then n is equal to 2, then 1 upon 3, then n is equal to 3, then 3 divided by 3 plus 1, 3 by 4, and in this way. Therefore supremum of all these terms is, this is 0.5, this is 0.33, okay, this is 0.75 maybe, okay, this is 0.75, okay, this is 1.5 means 0.2, and in this way their value is 6 8 something, okay, 8 something. In this way we get their supremum. In this way we get a supremum of these all terms, means this value is 5 by 6, this value is greater than 3 by 4. Then again next value is, suppose this value are less than 1 by 5, their value is 0.2, 1 by 5, 1 by 3, this value are less than, but 5 by 6, then 7 by 8, then 9 by 10, then 11 by 12, these all our value are increases. Okay, so supremum of these all terms is must be then Mn. Okay, Mn of these terms, Mn of these terms is must be supreme of 1 by 2, 1 by 3, 3 by 4, 1 by 5, 5 by 6, and in this way lastly n divided by n plus 1, and one value is 1 upon n plus 1. We get last value is highest value is must be when n increases, then last value greater value of all these element, greater value of this all element is must be n divided by n plus 1. Okay, therefore mn is equal to must be n divided by n plus 1, because this value is the greatest value of all these elements. When n increases, then their value is must be increases. Okay, so therefore limit of n tends to infinity, mn is equal to limit n tends to infinity n divided by n plus 1. We get here common n divided by here common 1 plus 1 by n remaining. Okay, n get cancelled. We get limit n tends to infinity 1 divided by 1 plus 1 by n. We get when n tends to infinity, 1 upon infinity is equal to 0, and 1 divided by 1 is equal to 1. So this is a value, this is a value of given limit superior. Okay, then limit inferior is small mn is equal to, small mn is must be infimum of these all terms, 1 by 2, 1 by 3, 3 by 4, 1 by 5, 5 by 6, and in this way lastly n divided by n plus 1 and 1 divided by n plus 1. In this way this is must be infimum, because 1 by 2 their value is 1 by 2 is their value 0.5, then this is their value 0.3, this is a less than 0.3 is less than 0.5, this is a 0.20, this is also less than 0.3. Okay, 0.2. In this way we get n increases. When n increases, the last value of must be mn, infimum of these all terms is must be 1 upon n plus 1. Okay, and therefore this 1 upon n plus 1, this is a smallest value of all these terms, and therefore mn is must be 1 upon n plus 1. Therefore limit n tends to infinity, mn is equal to limit n tends to infinity 1 upon n plus 1. We get value 0. Okay, when n tends to infinity, in 1 upon infinity is equal to 0. Okay, this is a infimum of Sn. This is a infimum of Sn. Okay, so this is a one example of our